Hi everyone, welcome to Trigonometry. Today we explore lesson 11, Trigonometric Equations, part 1. This video focused on solving trigonometric equations having angle theta. Example, solve each equation and write out the general solution. Let's take a look at the first one. Cosine x is root 2 over 2. We know cosine is positive in the first and the fourth quadrant. So here come the answer. X equal to first quadrant is pi 4, fourth quadrant is 7 pi over 4. What we know about cosine is that it has a repetition of every 2 theta, because it has a cycle every 2 theta, meaning that the next angle is gonna be plus 2 pi, and that gives us 9 pi over 4, 17 on this 7 pi over 4 plus 2 pi, so that gives us 15 pi over 4, and so on and so forth. We also have an angle on the left side, which we have to minus 2 pi instead of plus 2 pi. Well, we can represent this angle as x equal to pi 4 plus 2 pi k and 7 pi 4 plus 2 pi k. K is an integer. Okay, so next time we can use k as an integer. Let's take a look at B. Sine x tangent x equals sine x. In this case, move everything to one side. Sine x tangent x minus sine x equal to 0. Factor out of sine x, we have tangent x minus 1 equal to 0. We have sine x equal to 0. Tangent x minus 1 equal to 0. So here, x equal to dot minus pi 0 pi 2 pi. So it looked like that. X equal to pi k. K is an integer. On the other side, we have tangent x equal 1. Well, tangent is positive in the first and the third quadrant. So x equal to dot pi 4, 5 pi 4, and then we're going to add 2 pi to get to the next one. So that gives us the 9 pi over 4 plus 2 pi. That gives us 13 pi over 4. At a closer look, you see that, oh, we can get from one angle to another by plus pi. So this tells us that, yay, we can write the general solution as x equal to pi over 4 plus pi k. Very cool. Let's take a look at C. Sine square x minus sine x equal to. Now, to do this problem, let y equal psi x. From there, we see that y squared minus y, and we can move the -2 on the other side. We have a quadratic equation. So in order to solve it, factor y minus 2, y plus 1 equal to 0. Y equal 2, y equal -1. Do the backs up, y psi x, so psi x equal 2. That is not possible because psi is between -1 and 1. Absolute value of psi x less than or equal to 1. Y equal to -1. Well, sub y for psi x equal -1. The angles that give -1 is 3 pi over 2. And let's do the faster way here. And any repetition of it. So for every cycle, that is every 2 pi, we have another angle. And we plus 2 pi k. Yay! This is cool. Here come one more d. 3x squared minus psi x minus 2 equal to 0. Same thing here. Let y equal to psi x. 3y squared minus y minus 2 equal to 0. Factor it out. 3y plus 2y minus 1 equal to 0. So we have a 3y plus 2 equal to 0. Y minus 1 equal to 0. Y is minus 2 over 3. So y is psi x. Psi x is minus 2 over 3. Well, there is no angle that can give us this value. Because we only know the common angle. Pi over 6, pi over 4, pi over 3. In order to figure out x, we're going to have to use oxide. -2 over 3. And let's take a look at this. Let's see. It gives us, well, the best way to use this one is that's most scientific calculator. So oxide of -2 over 3. It gives us this number in radian. Right here, it's radian. We know psi is negative in the third and the fourth quadrant. Well, there is a negative angle, and that's in the fourth quadrant. We want to make it into a positive angle. So in order to do that, we can add 2 pi. So that is 1 is in the fourth quadrant. We need another angle in the third quadrant. So what we can do is that we can do the absolute value, right? And then plus pi. Now we get one angle in the fourth quadrant, another one in the third quadrant. And here come the answer. X is 3.87 with a repetition of every 2 pi, so plus 2 pi k, and also 5.55 plus 2 pi k. As for y equal 1 in the other equation, we have sine x equal 1. Well, x is pi over 2 and any pi over 2 plus 2 pi or minus 2 pi. So that is pi over 2 plus 2 pi k. Thank you for watching. I hope you found the content useful. Please like, subscribe to help the channel growth. I will see you in the next video.